Hello and welcome to Class Time. Remember, you can catch us live every weekday from 9 to 10 a.m. on TVJ and on onespotmedia.com.
You can also keep up with us on our various social media platforms and use the hashtag to make queries or answer online questions.
I'm Brittany Henderson.
And I am Wadian Price, your teachers for today's mathematics lesson.
All right, let's begin. Alrighty, so today we're looking at measurement. And our particular focus for this lesson is converting units of length, area, capacity, time, and speed. All right. Exciting lesson ahead, right?
Yeah, very.
All right. So, why do we need to be able to measure things? Why is this important? Why is measurement important? Any ideas?
Well, as you can see on the graphics, if you're going to buy a suit of clothes, a pair of shoes, then definitely you'd want to know your actual size.
So you tell me, say, I just don't want to just go and go figure it, just buy me a shoes. Just buy me a shoes? That can work?
Well, you can. Depends on how you want to walk in it.
Okay, all right. So we need some accuracy. We need to know exactly what size my shirt is, what size my shoe is, how long should I buy the piece of board, how, we need to know exact measurements. All right. So suppose we wanted to measure a 2 by 4 for building a house. Numbers by themselves?
Yeah.
It don't really make no sense, right? 2 times 2 multiplied
2 by
4?
4. Well, it's just that persons who are in the construction field may know when they say 2 by 4, or you hear they say 2 before, right? But that still don't give the full dimension of the board itself.
And me, as the layman, I got to the 2 before. I don't know what is the 2 before. So I would need a little bit more, right?
Definitely.
Okay. How about this? A board is 350 long. 350 long.
What?
Now I'm absolutely confused. Aren't you? 350
Very.
long? What's that?
What's that?
Exactly.
Nothing really.
All right. So units by themselves don't make sense either. So a board is meters long. No, oh boy, you're throwing me over the board.
Over the board.
Yeah. A meters long. What is that? So from this little exercise, to make sense of all the measurements, we need both our numbers and units.
Definitely.
So I need to know that it's 350 meters. All right? I need both my number and my units. Estimation. Why do we estimate? You remember I said to you before, just buy me shoes. You can just estimate from this.
Estimate.
Yeah, guesstimate.
Guesstimate.
Right.
So it's important at times. So although measurement is very important, there are times when you just really need an estimate, right? So, but it is very good that your estimate is close to the actual measurement.
All right. These 2 words, precision and accuracy. You hear these things a lot, don't it?
Yeah.
Why we need to be precise?
Well, as it says, precision is a description of how close measurements are to each other.
All right, so how close? And then we also need accuracy. So that's comparing the measurements to the actual or accepted value.
Yeah.
So you need both precision and accuracy. All right. So now I know that you guys are familiar with what is known as the SI system. Well, you should be familiar, right? Let's talk about this a little bit. So in the US, the English or the standard system is used, while most of the rest of the world uses the metric system or the SI system. The SI, which is International System of Units system, is the form of measurement typically used by scientists. Right. And scientists use the SI system worldwide because measurements are easily understood by all scientists, right? So we're making some standardizations here. Measurements are easier to convert than the English system.
Definitely.
Which we'll see in a little while, right? So those are the 2 main things. There's some standardization and it is easy for conversion, right?
Yeah.
All right. So the basic types of measurements that we want to look at are Length, which is measures the distance between objects. Volume, which measures the amount of space something takes up. And mass, which measures the amount of matter in an object. Right? And there are other types of measurements that we can talk about, such as time and temperature. All right.
So here we have the comparison now between the English and the SI system. So as we were having the discussion earlier offset about although we are using the SI system, we are using meter, centimeter, gram, kilogram, liter, there are still cases where we still use the yard, inches, pound, quart, and so forth. So all of these yard, inches, pound, quart, these are the English system. While in the SI system, now that is where you have the meters, the centimeters, the gram, the liters, and so forth.
Yes, that's certainly true, because when you go to the shop, it's a pound of chicken, no? You want a pound of chicken? Yeah, I'm going to really say, can I get a kilogram of chicken, please? No. All right. All measurement systems have standards. So we know that there are standards for conversion, for comparison. Standards are the exact quantities that everyone agrees to use as a basis of comparison. And the importance is there was an agreement among persons that this is what we're going to do and this is how we're going to standardize everything. So in the English system, when you have to remember a lot of things to convert, let's look. So 12 inches in a foot.
1 foot, 3 feet, 1 yard.
Go on, man. Continue. You're on a roll. Come back, Mr. Price.
Oh, boy. This was really heart-rending. Or still, because we still use them at times. You know?
So you have to remember all of these. And suppose I say, oh, but I wonder if it's 3 ounces make a pound, right? You have to remember all of these basic conversions to be able to convert from one unit to the next. This is tiresome. So the great scientists and persons who are, well learnt came up with the SI system, and this system is based on our number system. It's based on a base that uses the base 10 system, right? So which is something that we're familiar with.
Right.
So when we talk about place value, remember that thing?
Yeah, definitely.
Right?
So there's an easy connection right there between the base 10 system as it pertains to the measurement and the place value system.
Yes.
So there shouldn't really be any major challenge in terms of conversion.
There shouldn't be, but sometimes we have a little trouble. All right, so as was mentioned before, if you look at this table, this should remind you of our place value table. As you can see, we have our unit, which is our base. So we have units, which is 1, and as we go up, we're increasing by 10, and as we go down, we're decreasing by 10. So it's multiplied by 10 as we go up. All right, so the system works with the SI measurements. The unit becomes whichever type of measurement you're looking at. So whether it's mass, volume, or length. And it is the same regardless of if you're measuring length, mass, volume, which you said before. All right. So if you're measuring mass, then gram, and gram is your unit,
now,
right? And then we have variations, which is centigram, milligram. If we're looking at length, we have meter as our base unit, and then we can have variations, kilometer, decameter, and we can go on. If we're looking at volume, our base unit is liters. And we have variations, deciliter, hectoliter, so forth. So the first part of the term indicates the amount, and the second part indicates the type of measurement, right? So again, volume would be liter, and the first section, which would be deci, would indicate the amount of liters.
All right, so centi here would indicate the amount.
Yes, so centi is the amount.
And then gram?
And then gram is the type of measure, which in this case we're looking at mass.
Right.
All right, so let's look at some SI system conversions. I'm kind of excited now because we know that we're using the base 10 place value system, right? It's the same concept, increasing by powers of 10, decreasing by powers of 10, right? So, for example, in the metric system, if you wanted to know how many centimeters were in 3 meters, what would you do?
Question at home.
Oh, we're
What
throwing
will
it
you
out. So guys at home, if we wanted to know how many centimeters there are in 3 meters, what would you do? All right. You think them start
Right.
working? Them get
Start
it?
working, yes.
All right. Let's run it.
All right, run it.
So first things first is you want to first establish your SI system table.
Definitely.
Yeah. And as you can see here, we have our units, and then we have kilo, hecto, deca, deci, centi, and milli, right? The unit in this case is we're looking at meters. So that's our base, and we're converting from meters
To
to
centimeters.
centimeters. So 3 meters. First, you find the unit you have, which was mentioned before, which is meters. Then we find the unit you are changing to, which is, in this case, centimeters. And lastly, you then count the number of units in between. So we're going from our unit
Right.
to our centimeters. And we're counting the number of units between. And in this case, how many units between we have?
2.
Two units, okay?
Right.
And so, this case, we're going to be multiplying by 100. And 2 units then converts into, remember, we're increasing by 10, right?
So it's 10 and then 10 by 10.
Yes.
10 times 10 rather give you 100.
Yes, right. So we're moving to the right. So 3 meters is actually 300 centimeters.
Definitely. So we are seeing where you need more of the centimeter
to make
up the
meter.
The meter, because meter would be a larger unit.
Yes, yes. All right, and you know we have this little chart here.
Yeah.
These are the most commonly used SI units. So we generally use our base unit. We generally talk about kilometers, centimeters, and millimeters. We don't so much talk about the hecto, the deci, and the deca, right? So we generally focus on kilometers, or kilo, centi, and milli.
Yeah.
And as you can see, as we move to the right, so we're moving from a large unit to a smaller unit, we tend to multiply. And as we move from a larger unit, from a smaller unit to a larger unit, we tend to do the inverse operation, which is divide.
Definitely. But it is always good where we started out in terms of knowing the meaning of the prefix.
Centi.
Right? Right. It is always good to start there. Normally we see persons starting by using mnemonics. You know, the one that say, kick him down, hurry, don't commit murder. So students have to remember those mnemonics in order to know how do I convert. But if we know the meaning of the prefixes, then we can easily make the conversion. So we know that the centi would be 1/100th of the meter.
Yes.
For example, right? So that is very important.
Okay, so that's something that definitely, if you're taking notes at home, guys, write that down. Kilo.
Kilo.
Yes.
Means what? 1,000.
Okay, there
so
we
it's
go.
1,000 of the meter.
All right. So, guys, again, hope you're taking notes of that. So let's look at some more conversions. And here we have 2,321 millimeters. And we are asked to convert this to meters.
Yeah.
So, again, we need to identify our unit.
Our unit.
So we identified our units. Our unit is meters.
Yeah.
We're now identifying where we want to go, which is we want to convert.
So we're at
We're at millimeters, my bad. So our unit is millimeters, and we're identifying where we want to go, which is to the meters, right? The second thing we need to do is, again, find out how many units in between. And in this case, it's what?
1, 2, 3.
Three units.
So divide by?
We're dividing by 1,000.
1,000.
And so we have 2.321 meters.
And then we know how easy it is to divide or multiply by powers of 10. Right? So in this case, we see the numbers just moving. Right? Some persons would say it's the decimal point that really moves, but it is actually the numbers. Right? So based on whether we are multiplying by 10, 100, or 1,000, then those digits will move accordingly.
That is true. So here's one. So here's another one, my bad. So we have 521 grams to hectograms. You want to give them a second at home to just try this one? So we have 521 grams and we're converting this to hectograms. What you get? Remember, what's our step? Identify where we are, where we need to go, and count the number of units in between.
Yeah.
All right. I think they should get it by now, right?
They should.
All right. So it is 5.21 hectograms. How many units were in between the grams and the hectograms?
Just two.
2 units. And so as you can see there, we divided by 100. 8.5 kiloliters to centiliters.
Yeah.
Again, the same principles would apply. Identify.
Identify where you are.
Okay. Where we need to go.
Where you need to go.
All right. So we're at kilo. We're going to centi.
Yeah.
And how many units in between?
That's what, 1, 2, 3, 4, 5.
All right.
Yeah.
6, right? Okay. So it is 8,500,000 centiliters.
Yeah.
All right. So from this little power that we just have, there's some things that we need you to remember. We need for you to remember all measurements need both number and unit. 350, what does that mean?
Yeah.
350 meters, it gives me an idea as to what I'm looking at, right? So we're looking at length, for example. The basic units of measure are meter, liter, and gram. So this is very important for you guys to remember. The basic units of measurement are meter, liter, and gram. And we also need for you to remember how to convert your metric units. And how do we convert again, Mr. Price?
Well, you determine which unit you're using, whether you're at meter, centimeter, wherever, and then you look at where you want to go.
Okay.
Right? And then you count the number of spaces or gaps between where you are and where you want to go.
And the operation is also important. So whether or not we're going to be multiplying or dividing depends on whether we're going from a larger unit to a smaller unit or from a smaller unit to a larger unit.
Definitely.
All right. So again, back to the basic measurements, and we're going to dip a little further into them. So length again measures the distance of the between the objects. Volume measures the amount of space something takes up. Okay. Mass measures the amount of matter in an object. And our basic SI units are meter, gram, liter. Now, guys, we're stressing this for a reason, right? So please bear these things in mind. It's important for you to just remember them so it makes it easier for you to get on. All right. So now we're going to delve a little deeper into length. So length is the distance between 2 points. So it doesn't matter if it's width, height, depth, whatever. All lengths are measurements, right?
So it's not necessarily the longest side that we really refer to as length.
Exactly.
Right.
It's because the width is the length.
The width is a length.
The height is the length.
Exactly.
And the depth is also length.
Yeah.
Okay. All right. So the basic unit of length in the SI system, again, we've been stressing it all throughout the show, is meter. And meter is about the length of the English yard, or
so
3 feet.
Yeah.
Just throw that in there, you know, just if you wanted to make a little comparison. Because sometimes when you go into, for example, you go to the hardware store, they might say, you know, get me 3 feet of this or 4 feet of that and get me a yard of this. When you go to the cloth store, what is that really? So we, in Jamaica, although it is that we're a metric system, we use these things interchangeably. And so sometimes it's good for you to note these things.
Yes, definitely.
All right. So length is the attribute of the object. So length is the attribute of the object, right?
Yeah.
All right. So a variation of length is area. And I'm sure that you guys are very familiar with area.
We have done so many lessons on area.
Yes.
Right? So as we know, area is the amount of space enclosed in a particular region. So as we can see here, if we are finding the area enclosed in this region, we basically looking at how many unit squares, right, we can fit into this particular region. In this case, for example, we are using little centimeter squares. So definitely we are seeing we can fit 10 of these little squares in the length, 10 in the width. So we know that we will have 100 of these little centimeter squares covering this particular surface. So the area here would be 100 square centimeters.
Oh, so you mean if I really should measure everything, it would really work out to 100 square centimeters?
Yeah.
Interesting, right? All right. We're dipping a little bit deeper into mass. And mass is the measurement of the amount of matter in an object.
Yeah.
Okay. So here we have, gas, liquid, solid. And we know that the basic mass is grams.
Is gram.
Right.
Right. Right. And then here we have a conversion. Again, if you want to move from gram to pounds, because there are times, again, as you have explained before, when we really need to have this type of conversion. So approximately 454 grams would give you a pound. Right?
Oh, so you mean when I want a pound of rice is actually 454 grams?
Yeah. You can imagine going to a corner shop and say, give me 454 grams of rice.
Well, I don't know if we're there yet. I don't really know. I wouldn't probably use it. But it's good to know, right?
It is good to know.
All right. And mass. So the weight and mass are related, but they're not the same. And this is interesting because we use weight and mass to mean the same. Yeah, we use it interchangeably. So weight is actually the pull of gravity on an object. The greater the mass, the larger the pull of gravity.
Yeah.
Interesting.
Right.
So
here we are seeing the same person. Right? All these, they are the same persons. But on the moon, they are saying my weight on the earth is about 560 newtons. Right? While my weight on the moon is around 90 newtons. But still, her mass is 56 kilograms. So wherever she goes, although our weight is this amount on the earth, her weight is that on the moon, but her mass remains the same. So while the weight may change, the mass remains the same.
Interesting, isn't it?
Yeah.
Wow. Hi from the moon. How about volume? So
volume is the amount of space something takes up, right? And we know that the basic unit used for volume is liter, as we have said before. This unit is used for volume of liquid. So any form of liquid, your water, your cooking oil, your gas, all of these, we will use liters. Right now, how do we find the volume of a particular cube? Right, as we can see here, again, similar to what we did with the area, where we see how many of these little unit squares would fit in this particular region. If we will find the volume now, what we want to do is to find how many of these little cubes, 1 unit cubes, would fit in that particular, in this case, a cuboid that we want to fill up. Here we are seeing that this would take about 16 of those small cubes to fill up this large cube. So the volume in this case would be 16 cube centimeters.
All right. So guys, I hope that you've been enjoying it so far. So here's where we're going to take a short break and we'll be right back with more CSEC mathematics.
All right, welcome back. Let's pick up where we left off. Right, so we had just discussed volume and how we actually calculate volume. So let us move on.
All right.
All right, so here we are seeing now how can we find the volume of an object without a definite length, width, or height. Right, in this case, the volume of a rock. So we are not seeing a length, a width, or height, a definite length, width, and height. How can we find that? One way in which we can do this, whereas we have two measuring cylinders, here we are seeing the water level in the first one to be somewhere about 17.1 milliliters. Now, after we immerse the stone in the water, it went up to 19.8 milliliters. So here we are seeing a change. So that change must be the actual volume for the stone now, because it actually changed the volume from where it was before to a higher figure. So that is how one way in which we can find the volume of an object that does not have a definite length, width, and height.
Okay.
All right, and then from there we can find the mass as well.
Okay. All right. So, and we note that 1 milliliter is equal to 1 cube centimeter.
Yeah.
All right. So let's get into some activity. Leroy is planning to tile his driveway. He wants to know the number of tiles he should purchase. So he wants to tile his driveway, wants to make it look a little bit better, and he needs to now know how many tiles he needs to purchase. Yeah. So, firstly, Leroy measured his driveway, right? And he knows that one of the lengths is 15 meters. Another length is 8 meters.
Right.
And he also went ahead and got some tiles, right?
Tiles, right?
So, all right. So he went to the store now, and he found out the tiles that he liked. He got the measurements for those tiles. So it's 25 by 10 centimeters. So 25 centimeters by 10 centimeter tile.
But here he has a challenge now.
No, he needs to find out how many tiles can now fit in the area that he has, right?
Right, and not just that, but the driveway is measured in what? What's the unit
Meters.
there? Meters. While the tile is in
centimeters.
Yeah, so some conversion will have to take place for him to determine the number of tiles he's going to really need.
So Leroy has his work cut out for him.
Yeah.
All right. So we went ahead now and, just make it a little bit easier for you guys to see. So we have our driveway and then we have our tile. Oh.
Yeah.
The very first thing we need to determine is the area of the driveway.
Yeah.
Right. And so we determined the area of the driveway to be 120 square meters. What do you think is the next thing we need to find out?
We can find the area for the tile.
So we also need to find the area for the tile, bearing in mind the area for the tile is in centimeter. The tile, is measured in centimeter, and the area will therefore be in squared centimeters. So the area of the tile is actually 250 squared centimeters. Yeah. Okay.
All right.
Now Leroy has a problem. He knows the area of the driveway, he knows the area of the tile, but he cannot determine how many tiles can fit into his driveway until we have some sort of commonality.
Yeah, exactly.
Right? So we need to have both our area for our driveway and our tile in the same unit.
But which one would we convert though? Because we can convert the meters to centimeters as we did before. And we can also convert the meters too. All right, so whichever way, but which one would we convert?
I say, I don't know, the tile, because I want to know how many tiles can fit in there. No? I think we should convert the driveway.
Convert the driveway. Yeah. All right, so which one, remember the tile now is going to go in the
driveway.
In the driveway.
So again, convert your tile to figure it out. How much of it is going to go into your driveway?
How much of that is going to go in my driveway? So since we're going to put centimeters in this thing, then we want to know how many centimeters will go into our driveway. So we're going to convert our driveway, convert the meters, and see how many of that centimeter will go in this 1 centimeters now. All right? So let us do the conversion.
Okay.
All right? So converting.
To centimeters.
All right? All right. But a crucial thing here now, we're not just converting meters to centimeters. You realize that we're converting
meter square.
squared.
Or squared meters.
Or squared meters to squared centimeters.
Yes.
So someone may be asking, why do we multiply by 10,000 when we have just said that there are 100 centimeters give you 1 meter? Why 10,000?
Well, we just said it, we said we're converting squared meters to squared centimeters.
Right.
So that is the essential thing there.
That's the
It's
essential
squared meters, not just meters, but squared meters.
Squared meters.
So it's actually going to be.
Right. So since if we're looking at let us show it on the board.
Yes.
So let us say this is my square. Right. So it's a 1 meter by a 1 meter square. Right. But we know that 100 centimeters give you 1 meter. So this is really 100 centimeter by 100 centimeter. So the 100 times a 100 would give me the area.
10,000.
Which would give me my 10,000. Right? So that is how we get the 10,000 there. Right? So it is crucial because students normally make the mistake right here. All right?
So we're converting to centimeters, so it's going to be 1,200,000 squared centimeters. So guys, disregard this. It's supposed to be squared centimeters. All right.
All right. Right, so there we have the conversion.
All right. So now we can determine the number of tiles needed. So we have 1,200,000 squared centimeters, and we can now divide the area of our tiles to find out the number of tiles. And the area of our tile was 250 squared centimeters. So we need now 4,800 tiles.
Yeah.
That's a lot of tiles, though.
That's a lot.
That's a lot. You have a big driveway.
That's a big driveway.
Whoa.
Well, the tiles are not too big, really, when you look at it.
Oh, well,
so
maybe. Okay. So we're buying itsy-bitsy tiles. Now, Leroy has another problem. Leroy wants to reach the hardware before it closes. The speedometer below shows the speed at which he's traveling. If the hardware is 25,000 meters away, how long will it take to reach the hardware at this speed?
Oh. Right, so he's traveling, that looks like what? 81 kilometers per hour. Well, that is more than the speed you're traveling. Not you. This is obviously not you. Right? So he's traveling at 81 kilometers per hour. All right, so we definitely we're going to need some conversion again. All right, because we're looking at kilometers per hour, and the distance from home to the hardware is in meters. All right, so let us see how he works out this. Right, so in terms of conversion, we know that 1 kilometer per hour is equal to 999.99 meters per hour. Right, so he would know that. Then since he's traveling at 81 kilometers per hour, right, all he needs to do is do what now? Multiply 81 times the 9,999.99, right? And so he ends up with 80,999.9 meters per hour, right? So that is the speed he's traveling at now as it relates to meters per hour, all right? So he still don't reach where he wants to reach as yet.
All right, so now we need to find out how long it will take.
Yeah. All right. So definitely what we're going to do now, what is speed? Speed is distance over time. All right. So here we have 25,000 meters. We're going to divide that now by the speed at which he's traveling. We see that he's traveling at 3,100th hours. It will take him 3,100th of an hour to reach there. Converting that to minutes now, it will take him 18.6 minutes. Right? So when you look at it, the numbers look big, But when you actually do the conversion, you realize that
It's
won't
not that
really take-
long.
It's not long.
Right, 18 minutes, one
Yeah.
quick drive.
Yeah.
All right.
All right, so as we mentioned before about how we calculate speed, that speed is equal to the distance divided by time. Then based on that now, we know that we can transpose that same formula now to
Find.
arrive at whether we want to find distance or time,
Time.
or speed, right? And CSEC students normally use these triangles
To help them to remember.
help them to remember.
Yes.
Right? So using this triangle, we see that speed is equal to distance over time, right? If it is time, it's what?
Distance divided by speed.
Yeah.
And if it's distance, it's speed multiplied by time.
Yeah.
All right. So again, if you want to take a little picture, you may have it already, but you can take a picture. Activity time. It's that time of the morning. Aren't we excited?
More activities.
More activities. But these are the activities that we walk you through some, and we're going to throw these at you and then see what you get, and
Yeah.
we'll give you some answers. So the diagram, not drawn to scale, represents a map of a lane fields drawn on the grid of a 1 centimeter squares. The scale of the map is 1 to 1,250. So then you're asked to calculate the distance in centimeters from F to S on the map.
Yeah. All right. Question: why do they normally say not drawn to scale?
Because, all right, if I'm representing the field outside, on the paper, I really cannot draw the field outside.
Yeah.
So it's not drawn to scale. So I have to scale it down so it can fit on my sheet of paper,
Right.
right? So I'm representing this real life thing, but the real life thing cannot hold on my little 8x5 sheet of paper. So I have to scale it down so that it fits. However, you are now given the scale for the actual representation of the real thing.
Right.
So you know that it's 1 to 1,250. So that's the reason why.
And then there are also cases where the dimension may not be, if you actually use a ruler to measure on the paper itself,
It may not be accurate.
Be accurate.
True.
Right, so you just have to use whatever key that they give you.
Yes.
All right?
All right. So part 1, calculate the distance in centimeters from F to S on the map. So we need to identify our points, F and S.
All right, so we're seeing F there, and S is up here.
And we're asked to calculate the distance. No. Distance, we just looked at it before. How is it that we're going to calculate the distance from this?
All right, and looking at it, we're seeing that we have the slant height.
Yes, and I'm seeing
Right.
where I can form a little triangle.
Yeah, we can form a right angle triangle right there. So let us do that and see what happens.
All right.
All right. So here we have our right angle triangle.
All right.
Right? And this now should turn on a light bulb in our heads. Oh, right angle triangle, and I have 2 dimensions. All right. Obviously now Fs would be the hypotenuse of this right angle triangle. Right? So we can now go ahead and calculate the length of this side. All right?
All right, so I hope you guys, the light bulbs were turned on. And how is it that we got the five squared and the 6 squared units? Let's figure out how we got that. So from our diagram there, if we actually counted, so if we count F, S, and let's call that point down here. Let's call this point down here G.
Yeah.
So if we counted from S to G, would have gotten 1, 2, 3, 4, 5 units. And if we counted from G to F, we would have gotten 6 units. And again, as Mr. Price would have mentioned, we're finding the length of our hypotenuse.
Yeah.
And so we'd use our favorite friend, Pythagoras' theorem, to find the length of my hypotenuse. So it's actually 7.8 centimeters. And remember that we said from before, the grid is of 1 centimeter squares.
Definitely.
Right? So now part 2. Part 2 says, calculate the distance in meters from F to S on the actual field. So now we're going from centimeters, which we did in part 1, to meters, which we're now going to do in part 2. Now again, guys, at home, we would have gone through the steps that we take. We need to identify where am I? So where I'm at, where I need to go, how many units in between determine whether or not you are going to be multiplying or dividing. All right. So I'm going to give you like a minute, just a minute, and I want for you to tell me what you get. All right. They can do it, right? All right, let's see.
All right.
So here we
someone is asking, how this 1,250 comes in play.
Right, because I know that I'm going from centimeters to meters, so I'm just simply what? Dividing by 100. Right, so I know I'm dividing by 100, but 1,250. Remember that the question stated that it's the actual field. Right? And if we go back up top, we'll see that the scale of the map is 1 to 1,250.
Definitely. So on this map, when we see one centimeter, right, on the actual field, it is 1,250 centimeters. So that is why we had to multiply the 7.8 centimeter by the 1,250, right? Then that figure in centimeter will divide it by 100, and that will give us our calculation in meters.
And that's a very important thing to note. This is something that oftentimes you may miss. So again, when you're going through your questions, please underline the key points because actual field is a very important thing to note.
Definitely.
All right. Now, part 3 of the question says that Daniel ran the distance from F to S in 9.72 seconds. Daniel, faster than me.
Yes, sub 10. He's running sub 10.
Right. So he's asked to calculate his average speed in meters per second.
All right. Let's go.
All right.
All right.
So, okay, go ahead.
So the 9.75, right? That's the time that he ran. All right. We want to find the speed. Again, how do we find speed? Distance divided by
time.
And we have already found our distance to be 97.5 meters. So we divide that now by the time, and that will give us our speed, right? So the speed at which he's traveling is 10 meters per second.
All right, so Daniel is moving quickly. Part B says, in kilometers, we're asked now to give our answer in kilometers per hour to 3 significant figures. And again, that's a key point to note, 3 significant figures. So we have our time in meters per second, and we're now converting to kilometers per hour. So we will simply, so again, we have 10.0 meters per second, and we're going to multiply by 3,600 divided by 1,000, which gives us 36 kilometers per hour.
Right? So again, we could go through the calculation of the whole conversion. It's going to take up some time still, but normally we'd see that would multiply by just 3.6, right? If you're converting from meter per second to kilometer per hour, we just multiply that figure by 3.6. Right, and we could go through the different conversions. So there we see our answer. Now, why didn't we just write our answer as 36 kilometers per hour?
All right, so because as stated before, it is important for us to write it to 3 significant figures.
Yeah,
right?
That's important.
All right.
All right, we are going on our final break. When we come back, we'll wrap up things. Soon come.
All right, so welcome back to class time and let's continue with our lesson. So we left off with converting Daniel's average speed to kilometers per hour, and we got 36.0 kilometers per hour. Now we were having a discussion as to why it is that we wrote 36.0 kilometers versus just 36. Now, as we noted from before, it is important for us to write it to three significant figures. And here, when we look at 36.0 kilometers, this is actually three significant figures, right? Yeah. So 36 by itself is only two
significant figures.
So that is the reason why we have to write the point zero.
Definitely.
All right. So now in the diagram below, it shows a map of an island drawn on a grid of 1 centimeter squares. The map is drawn to scale of 1 to 50,000. Copy and complete each of the following sentences. 1 centimeter on the map represents?
Right, and that's a giveaway because it's right there in the scale.
50,000 centimeters. On the island, an area of 1 squared centimeter on the map represents the area of dash squared centimeter on the island.
Yeah. How would we get that?
All right. So again, if it is that 1 centimeter is represented by 50,000 centimeters, if we're doing the squared centimeters now, it's just simply 50,000 multiply 50,000. Right? So we would then get
a big number.
Very big number. Squared centimeters.
5 million.
Squared centimeters.
Squared centimeters.
All right,
that's
parts.
a big space.
It's a big space.
Well, when you look at centimeters still, very small unit. So.
Yeah. So part 3 says, given that K is 100,000 centimeters, a distance of 1 centimeter on the map represents the distance of dash kilometers on the island.
Right.
Right. And again, now we're converting 100,000 centimeters to kilometers. And we know from before that we had 50,000 centimeters. We divide that by 100,000 and we get 0.5 kilometers.
Yeah. All right.
The very last question now. L and M are 2 tracking stations. State in centimeters the distance of LM on the map. So let's identify LM on our map.
Right. So there's L and M is right there.
All right. And we now need to calculate the distance from L to M on the map for the 2 tracking stations. No, we got 8 centimeters. Yeah. How did we get this 8 centimeters?
Right. But it's really, when you look at the words used, initially they said we should calculate. Now they said state. So it simply means I can just look on my map and just count. I don't have to do any form of calculation.
Okay.
Right? So if I count all these dimensions of the squares. So it's 1, 2, 3, 4, 5, 6, 7, 8.
All right.
So that's just the length of that line.
So easy peasy. Yeah. You know, sometimes you see these questions and you're wondering, oh my
exactly.
gosh, what's
But
happening?
if we pay attention to these keywords, calculate versus state,
it will give you a hint as to what is required of you.
How much work is really needed. Okay. And this will value maybe about a 1 mark.
And that too also gives you an idea as to how much work you need to put in, because you'll see the marks on the paper. If it's a 1 mark question, really and truly, guys, it's more like look and state something.
Definitely.
And if it's maybe a 2 or 3 mark, you know you need to put in a little bit more energy. So part 5 says, calculate the actual, no guys, this should be actual distance in kilometers, right? So we now know that from L to M is 8 centimeters, and we're going to multiply that by 50,000 because again, we know the actual, you know, it's 1 to 50,000 on the map. And so here we're going to get 400,000 centimeters, but you're required to write it in kilometers. So we then need to convert our centimeters to kilometers.
Right.
And we do that by dividing by 100,000. And we would get 4 kilometers.
I remember they would have given us that 100,000 already.
In previous parts,
previous parts. So we have to pay attention. So that is what, as I said before, these are questions that students normally really just mess up in the exam because they are not paying attention to the scale given. They're still thinking about, all right, 100 centimeters given 1 meter, but what is the scale that is actually being used in this particular question, right? So it's very important for them to really look, ensure that they check and double check the unit that is given, the scale that is given, and the unit that is required for your final answer.
So do you recommend now that when you read through your question, you kind of have a little jotting, a little side notes where you have all of these important things? Because sometimes, you know, you're moving through the question really quickly and you forget that in a previous section, this information was given. So maybe as a little exam tip, you can have a little section on your paper where you write down the key points. Some persons like to underline, but sometimes you underline and forget. So write down the key points so that as you move through the question, you realize that each section is related, you can now refer to these key points. Right? A little exam tidbit right there. All right. So part 6 says, let the area shaded on the map be the forest reserve, right? So by counting the squares, estimate in squared centimeter the area of the forest reserve as shown. Right.
And here now, remember in the first segment, we spoke about estimation.
So again, you can easily well do a little estimation, right? So for this particular thing, we're going to ask that you guys take a little picture of it, screenshot it, take a little picture, and we're going to call this homework. All right? So take a picture right now, and homework it is.
All right.
All right. Oopsie. All right. So that's all the time we have for this lesson. Thank you so much for joining us today. Please stay safe over the weekend. Until next time, keep safe.
Keep safe.
All right.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.